Before jumping in the video for volume of prisms, I have the timestamps for the various shapes that are covered in this video. So to respect your time, if you need to jump forward to a particular type, say volume of a cylinder, you would just go to 4 minutes and 54 seconds. So you can find the volume of any 3D shape where the front and rear face of the shape are identical. And this is definition for our prisms. So here, the front and rear face are triangles. Here, the front and rear face are hexagons. Here, they're both circles. And here, the front and rear faces are rectangles. A cube, the front and rear face will be a square. Now, finding the volume of a cube or a right rectangular prism is, before we had learned that was length times width times height. And what I'm going to introduce here is that the length times the width, well, that's the area of the front face. If we were to call the front face beta, it's just going to be a generic term, and we multiply by the distance between the front and rear face, it gives us the volume of any prism. Cylinders, hexagonal prisms, anything that you can think of as long as the front and rear face are the same. So here we have a right rectangular prism, and what I'm going to do is I'm going to find the area of this front face and then multiply by the depth, which is the distance between the front and the back. So the volume equals beta, which is the area of the front face, times the depth. And in this case, beta is the area of a rectangle, so I'm going to put in the formula for the area of a rectangle. The base is 11. Use a different color here. So the base is 11 and the height is 20 for this front face. So it's going to be base times height for the rectangle times the depth. Now I'm going to substitute, and when I substitute, I want to use parentheses. So the base is 11. We'll add units in later. The height is 20. And the depth is the distance between the front and rear faces is an 8. So when I multiply, I'm going to multiply 11 times 20, which is 220. And then I'm going to bring down the parentheses with the 8. And then I'm going to multiply 220 times 8, which is 1760. And in 3D geometry, our volume is going to be the unit squared. In this case, it's inches, inches cubed. So I bring down my V. So the volume is 1,760 inches cubed. That one's done. So here we have a glass prism, and the front face on this is a triangle, and the distance between the front and rear triangles is 9. I start off by writing the formula for all prisms, which is volume equals beta times depth. Beta in this case is the area of a triangle, so I'm going to put the formula for the area of a triangle, which is 1/2 base times height, and then I bring down the depth, the d for depth, and then I plug in my numbers. So I have 1/2. The base of the triangle is a 4. I want to put that in parentheses. The height is a 3. If I didn't put these in parentheses, I would have 1/2 of what looks like 43. So use parentheses when you substitute. And then d is the distance between the front and rear faces, which is a 9. I want to get rid of that fraction right away, so I'm going to take 1/2 of 4, which is 2. And then I'm going to do 2 times 3 is 6, and I bring down the times 9. And 6 times 9 is 54. My units are inches, and since it's a a triangular prism, it's cubed. So I bring down the V and box my answer. Here we have a cube, so when we're doing this, so volume equals beta depth. The front face is a square, so it's going to be base times height times depth. And then I'm going to substitute using parentheses. So the base is 3 inches. Height is 3 inches. And the depth, which is the distance between the front and rear face, is also 3 inches. 3 times 3 is 9. Bring down the times 3. So our volume is going to equal 27 inches cubed. Now a cylinder also is a prism. Its front and rear face are identical and they're separated by some distance. So I start with volume equals beta times depth. Beta is the area of the front face, and the front face is a circle, so I put in the formula for the area of a circle, which is pi times the radius squared times d. Now, pi is 3.14, so I'm just going to put that in there now. And the radius, well, the radius is 8, and 8 squared is 64. And then the distance between the front and rear faces is 15. So now I simply multiply. So I'm going to do 3.14 times 64, which is 200.96. I bring down the times 15. And then I'm going to multiply 200.96 times 15, which is 3,014.4. And just as before, we put our units cubed. So if your calculator has a button that is pi, your answer is actually going to be a little bit bigger than this. So just be aware if your teacher wants you to use an exact value for pi, then you're going to have to use a calculator with the pi button. Now, depending on which grade you're in, calculating, this is a hexagonal prism, but it would work for any shape that's on the end of the prism as long as they're identical shapes on opposite faces. So if this is a pentagon, octagon, any shape on the end, if you're given the area, or you can find the area of the front face and then multiply by the distance between the two faces, you'll get the volume. So here I have volume equals beta depth. And this was actually a type of problem that you would see, say, in a 6th grade or 7th grade even textbook would give you. It would actually have a capital B here for this notion of what beta is. So the area of the front face, beta, here, we're not going to put the formula in because it's not going to be appropriate for the grade level of this video. Here, the area of the front face is given, and notice this is in square units, which is area. So when I substitute, I'm going to have 14.4 for the area of the front face times the distance between the front and rear face is 10. Then when I multiply them, I just move the decimal one space, because when you multiply by 10, you're just moving the decimal. So it's 144. This is inches cubed, and that's the volume. So it's pretty simple when you get a problem like that. Calculating the area of various geometric shapes like this is a subject of another video.